Exciting. A project for the course is a kernel deep dive, trying to make changes in the kernel and seeing it for real. The obvious problem we found was the inefficient file access, and we tried to work on it. The problem statement: when we look at a file system performance and the issues related to it, a fundamental challenge that crops up is the design of effective block replacement algorithms to minimize the buffer cache misses. All the existing buffer cache replacement algorithms have neglected the file system prefetching that exists in modern OSs. But prefetching is expected to have an impact on actual disk IOs as well, so that was a pretty big deal for us. Previous work was done by Accusym, which is a simulator, uh, apparently a trace-driven simulator that implements kernel prefetching and IO clustering algorithms. It interfaces with a realistic disk simulator and allows the user to find the hit ratio, number of disk requests, and the execution times of applications, and also the IO time. So as you can see, it has a simulator driver, and using the strace command on Linux, we are able to find the number of traces and all the information related to the inodes and the execution and the computation times. Next, we move on to the approach that we initially took. So building up from the Accusym simulator, we tried to implement a kernel implementation of algorithms. Um, these are words from the Accusym paper. They say that a kernel implementation of algorithms is laborious, which made us take the challenge to try and code kernel-based tools to implement various algorithms, as we said. Linux stopped the support of the buffer cache individually and combined that with the page cache, which made it kind of impossible to gather the information that we needed, specifically like combining the buffer cache with the page cache, and we are not able to identify the IO times for the file access. So that was a problem, and we moved on pretty late in the quarter, but still we moved on and tried to use the LD preloader, that is a dynamic preloader, to override an existing function and compare the prefetching approach with the existing one. Now we decided to have a web server based file request module and 4 different replacement algorithms, that is a least recently used, least frequently used, 2Q, and adaptive resource control algorithm for the comparison of the cache hit ratio, disk IO requests, and the IO time that is required. This is what happens without prefetching, where there is a website which requests through post, and the file request is sent to the disk, and the disk is accessed and returned, and the file content is displayed. So every time you have a post request that is requesting a file, you have to go to the disk and read it again and return it. With prefetching, what happens is you have the post request that goes in, a file request is sent to the cache. Now, cache is a dynamic memory. Now, if it hits, you just get the page out. If it misses, you fetch it from the disk, and it is returned from the disk and is displayed on the website either from the cache itself or from the disk. Now, this is what happens from the front end. At the back, there are cache replacement algorithms that run that keep on populating, repopulating, and removing pages from the cache and towards the disk. Now, that's what we talked about, the 4 replacement algorithms that keep on updating the cache. What did we achieve till now? We have been able to get the web server in. So since we started pretty late for the web server based implementation, and it is based on a Lambda school approach, and we created a memory disk page and a page cache structure. And let's look at a live demo for the page structure and to the web server folder, and we'll start the server. So this is the whole server written in C, and it runs on 3490 port. And we can see, we'll just go into the index.html file. of the file we want to access, which is done at the, we have the listed was accessed from the disk. When we implement the prefetching, we will be able to um, get the file from the cache, because this file has been repeatedly been accessed. And if we try to get a file that hasn't been accessed according to the algorithm that we have, we would have similar results. So we'll be building on this demo in the per se future. On to the expected results now that we're implementing it. We're implementing the prefetching and the replacement algorithms as we talk right now, and which we'll try to compare the hit ratio, number of clustered disk requests, and the execution time of each one of them. And we expect the result to be something similar to the base paper that we're looking at, and hopefully we get something out. Speaking about the overview, the file access is compared with and without prefetching, and we will be implementing the 4 replacement algorithms. Over the quarter, we have dived deep into the kernel, as we said in the beginning, which has been pretty exciting. And we had a lot of system crashes for the first approach, because we were implementing right in the kernel, and we moved on to the user space to simulate the page cache for the web server. And we hope to get a proper comparison out for the 4 replacement algorithms, and similar results to the base paper that we have. Yeah. Any questions? We're open for that. Thank you.